Assalamualaikum and hi everyone. We are from Group 3 with foreign code is EE112 and the course is MAT183. Today we will be presenting about techniques of differentiation. My name is Muhammad Amar, 2025409596 as the leader, and this is my group member, Muhammad Ilham, 2025889974, and Muhammad Ikhwan, 2025285034. Our presentation will cover technique of differentiation, derivative of integral, exponential and logarithmic function, the chain rule, implicit differentiation, linear approximation and differentiation. With further delay, I will begin our presentation with the first topic. What is the differentiation? Differentiation is the process in the calculus of finding the rate of change of a quantity at a specific moment. Instantaneous rate of change. It tells you how fast one quantity changes when another quantity changes. The second is, what is technique of differentiation? This technique of differentiation is rule and method in calculus to find the derivative of a function, simplify the process, complete limit definition. The method used when function is too complicated to differentiate directly. The main technique of differentiation is definition of derivative, the derivative of standard function, product rule, quotient rule, chain rule, implicit differentiation, sum and difference rule, and lastly linear approximation. The question was to use the definition of differentiation to find f prime x of y equal 4 minus 6x. For the function y equal 4 minus 6x, we calculate 4 minus 6 open bracket x plus h minus open bracket 4 minus 6x. Simplifying this difference give minus 6h. Next, we divide this difference by h, who give minus 6h over h. Finally, we take the limit as h approaches 0. Since the h cancel out, the result is simply minus 6.
Hello, Assalamualaikum. My name is Muhammad Ikhwan bin Marwan. So today I'm going to explain to you about 2.4 derivatives of trigo, exponential and logarithmic function. So look at to the first question. Find d1 over dx for y equal to second x plus 1 over x plus 2 close bracket power by 2. So we need to remember about the derivative for the function second x times x, second x, and it will be second x times x plus, and you need to put x plus 2 power by 2 to the top, and it will be minus, and the power will be minus. And just solve this as usual. Put negative 2 to the form, and minus by 1, and don't forget to differentiate x plus 2, and it will be 1, and 1 will be times by negative 2, and it will be negative 2. But we are not done yet. We need to put this like this, so we need to put it to the below, and it will be second x tangent x minus 2 over x plus 2 close bracket power by 3, and this is your final answer. And we look at to another question. Find d1 over dx for y equal to 4 longs open bracket x power by 2 plus 6x close bracket. So we need to know about the derivative of function ln. So ln is 1 over x, so it will be like this: 4 times 1 and over, and you need to put write down again x2 plus 6x, and it will be like this. And don't forget to differentiate x2 plus 6x, and it will be like this. And don't forget to times by 4, and this is your final answer. I also going to explain to you about 2.5, the chain rule. So we look at the question. Y equal to 4x plus x power by 2, close bracket, x, close bracket, power by 3. How to get dy over dx? Dy over dx equal to dy over du. I assume that we have u and x. Okay, so I assume y is equal to u power by 2 and u is equal to 4x plus x power by 2. We are going to differentiate u, and it will be 2u. And I am also going to differentiate x as well, and it will be 4 plus 2x. Hence, 2u times 4 plus 2x. dy over dx is equal to 8u plus 2ux. But we are not done yet. We know u has a value 4x plus x power by 2, and you need to put in, and it will be like this, and expand it. And so the final answer is 2x power by 3 plus 16x power by 2 plus 32x. So that's all for now.
For question 246, implicit differentiation, the question was to find dy per dx of xy plus y square equal 4 using implicit differentiation. We differentiation both sides with respect to x, treating y as a function of x. For xy, use the product rule. For y square, use the chain rule. The derivative of the constant 4 is 0. Combine term and solve for dy per dx. Answer is dy per dx equal to minus y over x plus 2y.
Assalamualaikum, my name is Muhammad Ilham. Today I'm going to be presenting chapter 2.7, linear approximation and differentials. Okay, the questions. A cube has sides of length as units. If the side length increased by 3%, estimate the percentage change in the volume of the circle. Okay, for step 1, the volume of a cube is the total three-dimensional space it occupies. For a cube, the length, width, and height are all equal in measure. We can represent the side length as a variable often as. The formula for the volume V is derived by multiplying these three dimensions together, which is this is typically expressed as Vs equal to S powered by 3. The first, in this context, we are looking at how fast the volume V changes as the side length S change. Starting with our function Vs equal to S powered by 3. Using the power rule of differentiation, we can find the V prime S. The resulting first derivative is V powered by V prime S equal to 3S powered by 2. For step 2, identifying the given values. The starting value of the side length is defined simply as S, and the side length is changing to 1.03S. This represents an increase of 3% from the original value. For delta S, the total change or the increment delta S is explicitly stated as 0.0S. This is the difference between the new value and the original value. For step 3, approximate the change in value. The fundamental formula used here relates the approximate change in a function output delta V to the function derivative at a specific point V prime S 0 multiplied by the change in the input delta S. In the previous step, the derivative was found to be V prime S equal 3S powered by 2, and the change in side length prime S was 0.0S. These values are substituted in the approximation formula. By performing the simple multiplication, 3 times 0.03 equals to 0.0 0.09 and combining the variables s powered by 2 times s equals to s powered by 3. By 3, we arrive at a final expression for the approximate change in volume prime V equal to 0.09 s powered by 3. Step 4. This step calculates the final percentage change in the volume of the cube using the approximated change found in the previous steps. The percentage change formula is standard, the change in quantity delta V divided by the original quantity V, all multiplied by 100%. From the formula, we substitute the values we have already determined, which is the approximated change in volume delta V into 0.09 s powered by 3, the original volume V into s powered by 3. For the calculation, that the s powered by 3 terms in the numerator and the denominator cancel each other out, which leave 0.09 times 100%. This yields the final percentage as 9%. In the overall answer is a 3% increase in the side length result in an approximate 9% increase in volume. That's all from me.
Now we are in the end. So for the conclusion, techniques of differentiation provide a complete set of methods for finding the rates of change of almost any function. Complex functions can be broken into simpler parts and differentiated efficiently. Overall, these techniques form the foundation for analyzing change in mathematics and real-world application. So that's all for our team. Thank you for watching.